Hello and welcome everyone. My name is Matt Bono and I'm an Extension Support Specialist with the GLASE Consortium here at Cornell University. Today we're sharing another video in our series focused on greenhouse energy and carbon benchmarking. Before we get started, I want to take a moment to briefly introduce you to the GLASE Consortium. So we are the Greenhouse Lighting and Systems Engineering Consortium out of Cornell University, and we're here to transform greenhouse lighting and systems management to support climate-smart CEA. And we do so by conducting research and educating growers so that hopefully emerging technologies can be adopted faster, which will help growers save money and ultimately reduce the environmental impact of energy use in greenhouses. What we have here on this slide are a few of the main ways that we support the CEA industry and our GLASE members. And so, as I mentioned, our research is focused on greenhouses, but also includes indoor agriculture. And we seek to facilitate technology transfer by showcasing those technologies' results on plants. We also provide webinars, technical articles, short courses, and other workforce development initiatives to educate growers in the CEA industry at large. And finally, our membership values our networking benefits via our industry advisory board meetings, as well as our annual GLASE Summit. I want to take a moment to call out a resource which is new and that we'd like to call the GLASE Library. And so uh, hello and welcome everyone. My name is Matt Del Bono and I'm an extension support specialist with the GLASE Consortium here at Cornell University. And today we have a hello and welcome everyone. My name is Matt Del Bono and I'm an extension support specialist here at Cornell University and the GLASE Consortium. Today we are sharing another video in our series focused on greenhouse energy and carbon benchmarking. Before we get started, I want to take a moment and welcome you here today with a brief introduction to the GLASE Consortium. So, we are the Greenhouse Lighting and Systems Engineering Consortium out of Cornell University, and we're here to transform greenhouse lighting and systems management to support climate-smart CEA. And we do so by conducting research and educating growers so that emerging technologies can be adopted faster and hopefully help growers save money and reduce the environmental impact of energy use in greenhouses. Now, what we have here on this slide are a few of the three main ways that we support the CEA industry and our members as well. And so, hello and welcome everyone. I'm Matt Del Bono and I'm an extension support specialist here at the GLASE Consortium out of Cornell University. And today we're sharing another video in our series, which is focused on greenhouse energy and carbon benchmarking. Before we get started, I'm going to take a moment here to welcome you with some information about the GLASE Consortium. So we are the Greenhouse Lighting and Systems Engineering Consortium out of Cornell University, and we're here. Our mission is to transform greenhouse lighting and systems management to support climate-smart CEA. And we do so by conducting research and educating growers so that hopefully emerging technologies can be adopted faster, and which will help growers save money and ultimately reduce the environmental impact of energy use in greenhouses. What we have here on this slide are a few of the main ways that we support the CEA industry and our GLASE members. And so, as I mentioned, our research is focused on greenhouses, but also includes indoor agriculture, and we seek to facilitate technology transfer by showcasing research and technology results on plants. We also provide webinars, technical articles, short courses, and other workforce development initiatives to educate growers in the CEA industry at large. And finally, our membership values our networking benefits via our industry advisory board meetings and the annual GLASE Summit. I want to take a moment to call out a new resource, which is the GLASE Library. The GLASE Library is a central place where you can access past webinars and other resources. And we also have our previous short courses, which are available to view and purchase on demand for non-GLASE members. And so we encourage you to bookmark this page or scan the QR code there to check that out. Our members are very valued, and we hope that you're potentially interested in joining GLASE. And so If you would like to learn more, you can contact our team for additional information on membership benefits and our various member categories. So please feel free to reach out if you'd like to learn more. Lastly, I want to highlight a new membership initiative called Vivid Canopy, where folks working in the CEA industry can connect and organizations can showcase how they are leading by example and hiring a more diverse workforce. So we hope that you're interested in potentially learning more about Vivid Canopy, and you can join our LinkedIn group and get connected. So with all that being said, I want to thank you for taking a moment to learn about GLASE, and you'll now be hearing from our GLASE Executive Director, Gretchen Schimelpfenig, and as well as our Principal Investigator, Dr. Neil Mattson, in another segment of our Greenhouse Energy and Carbon Benchmarking series. We hope you enjoy.
Welcome back. We're going to continue our video series on greenhouse energy and carbon benchmarking. I'm Gretchen Schimelpfenig with the Greenhouse Lighting and Systems Engineering Consortium, GLASE, here at Cornell University. We previously talked about how to measure greenhouse energy use and associated carbon impact. And today with Dr. Neil Mattson, one of our principal investigators at Cornell, we're going to dive into some alternative to fossil fuel use. So if folks want to sort of change the way their energy use is impacting their carbon impact on the environment, they can also adjust the ways they're using fuels and electricity. So the first question I wanted to ask is to Neil, when should greenhouses consider alternative fuels and why?
Yeah, thanks for introducing this topic, Gretchen. This is a big one. So I find only some greenhouses use lots of electricity, like for supplemental lighting, but all greenhouses that operate year-round, at least in northern climates, need to keep their greenhouse heated, and then in the summertime they need to keep it cooled. And right, traditionally those are fossil fuels like natural gas or fuel oil or propane. So overall, the framework that I kind of walk through growers through if they are considering alternatives is one, are they indeed heating through much of the winter? So as we know, most of our heat bills come in those coldest winter months. And so if you are a more seasonal operation that is operating from spring to fall, that may not be the best return on investment for your energy efficiency dollar. So do you heat most of the winter? What are other alternatives that you have? And so we do think of like biomass heat, where we have wood or some other waste resource that we have access to. So is another material available locally and/or inexpensive, including kind of all of the costs that would be associated with that. And that includes shipping or transporting that to your facility. Do you have the space to store that material on site at your facility? Can you store a year's worth of wood to keep your greenhouse heated? Have you also budgeted the labor to process that? So I remember visiting a pretty large, it was a 7-acre heated greenhouse operation, and they switched to wood heat. And for them, the economics made sense and actually budgeted for a full-time staff member that was essentially processing the wood for the operation. And they also budgeted for those maintenance costs that they were going to be incurring during the year. Is that material that you might have consistently available? So if we have lots of wood this year or some other biomass source, is that going to be available next year? And is it going to be consistent from year to year so that I can process it the same way? So the other things I think about are how are we disposing of ash or waste material? Is it allowed to be landfilled, or is it allowed to be applied to other agricultural land that we might have surrounding the greenhouse? And again, looking at all of those costs collectively. So it's not just changing out that furnace. It could be changing out other radiators or vents to supply that heat around the greenhouse, and then all the associated labor as well. So that's kind of the framework that I think about. Are we thinking about this from all the different angles, and is that a consistent local source that we have?
Yeah, and so you brought up a good point about is it available and is it inexpensive? And so let's take a look at the next slide that compares some 2024 costs for different fuels. And why don't
Mhm.
you maybe share with me how, maybe in the context of some of the greenhouses we've worked with, how has the cost balanced out for making choices of switching fuels, maybe electrifying or maybe not in 2025?
Yeah, great, great. So I want to reference John Bartok, who's a retired greenhouse engineer from the University of Connecticut, and we'll share a link with this presentation that has these calculations. So essentially, you can for different fuel sources, if you know the efficiency of that furnace, you can calculate the cost to produce 1 million BTUs, or that's kind of our standard unit of heat. And so I love looking at those calculations because these prices are dynamically changing, as you noted, Gretchen. So it would be we don't want to just think about this as a snapshot in time, like Neil plugged these numbers in 2024. Let's think about it based on the electrical cost that I have in my location or the natural gas cost that I have in my location. So one of the trends that we've been seeing the past few years is that natural gas is indeed kind of the cheapest way to heat a greenhouse, at least comparing some of these other fossil fuel based sources. And However, wood pellets or cordwood or waste wood can come close to it. So even if you pay market price for wood pellets, which require very little handling, you can start to approach natural gas prices. Um, so we think about what is the current price, what might be the long-term price trends, and then what are the alternatives that work for me. So if I think about this like from my own household. I live in a location where I don't have access to natural gas. And so right now I'm on propane, which is I have a delivery company and I can get propane that way. But I'm looking into other energy efficiency upgrades in my own home, like wood heat or using like geothermal, which we'll talk about later. Um, and what I've seen is some growers, when these fossil fuel prices are high, tend to look at alternatives to fossil fuels, like wood pellets or cordwood. And what I found is some greenhouse operations, like the concept of wood pellets, which come in a very uniform size. They come with a very uniform moisture content, so you can handle them in the same way. They're kind of self-feeding through the heater. So I've seen some growers that really resonates with them, and that's been the alternative that they've installed. And then I've seen some growers that tend to be more like do-it-yourselfers, and so they've installed wood boilers, and they get waste wood from landscapers, for example, or land clearers, and essentially they take that wood for free, which displaces any landfill costs or composting costs from that wood. And then they have an employee that processes that wood and splits the wood and keeps the furnace running. And for them, the savings that they incur make it worth their while. And then finally, I'll just say I have seen some growers that even within fossil fuels have chosen boilers that can be flexible in terms of which fossil fuel they can use. And sometimes there are like relatively easy to switch out components in that boiler so that it can process a different fuel source. And so that allows them to be flexible when, say, there's spikes in like fuel oil costs, but maybe something different has a more stable price, for example.
So this is a good commentary on resiliency, really just planning for the current price of fuels and electricity and comparing them and deciding what's worth it for today's price, but also for if potential volatilities or dynamic pricing happens for different fuels in the future. So we've talked a lot about wood, and I think our next slide is about biomass heating. And so for folks, especially on the fossil fuels that cost more like propane, biomass heating can be a nice complement, maybe as a secondary stage of heat, or one that essentially is going to help buffer them from having all of their heating costs be from that really expensive fossil fuel. So, Neil, why don't you tell us? You mentioned a few of your greenhouses you've worked with that use wood. I work with a greenhouse that has wood, and they don't use wood pellets, and that is actually one of the things that is a bit of a deterrent for them for having it be their primary source of heat, because it is such a labor intensive thing to manage the harvest of the wood from forests on site and then manage the wood furnace, and really much more manual labor when you're doing cordwood.
Yeah, I think that's a good talking point, Gretchen. And I'll even say that with chips. So I had a project with the greenhouse where their plan was to use municipal wood chips. So the municipality would get branches or trees delivered to them. They would chip them up and then they could compost them. But their alternative was giving them to this greenhouse for free. And theoretically, this was going to work well with the wood furnace that they had. What we found is that, and maybe no surprise, not all chips are equal. And so twigs move through and like clog conveyor belts. And so what they found is it was all about, it was theoretically a free source of wood, but it was all about how they screened and processed those chips to get a uniform size component and to get rid of extraneous material. And then they were actually able to use them for heating their operation. Um, so overall, biomass can be a viable alternative. I also like a talking point you had, Gretchen, which you might still have a backup heat source. And so maybe you have an existing boiler that's a fossil fuel boiler, so you could keep that on site and have that be a backup source, or have that kick in when your wood boiler doesn't provide enough heat on those very coldest nights, for example. So it is really nice to have that redundancy when you're using biomass heat, because there can be some downtime with maintenance, or the example of chips clogging the conveyor belt and the heating system going down until that was fixed.
I think that's a fair point for HVAC systems in general, especially with heating and in the north. We can't really deal with a single hour of plants being below a certain temperature. And so there's generally a good plan to have more than one source of heat. If you can have a backup source, maybe if it's not run that often, but is maintained so that it can in emergencies or during maintenance downtime, those are really good things to think about. No reason to have only one heat source. If you are replacing a heat source, you can always keep it on site so it's available in case of the new system needing to be taken down. So some other alternatives to fossil fuel heating, we, as you saw in the table of costs, do note that electricity-based heating systems are generally going to be more expensive to operate. However, if there are other reasons why you might want to have an alternative to fossil fuel, it may be more motivating to you than just cost. For some folks, it may be that there's not a reliable source of fossil fuels, or fossil fuel costs are increasingly volatile and you want to have a reliable source that you can predict. Electricity costs do increase over time too, though. I was talking to Neil before we recorded this video, and we both mentioned that we haven't worked with many greenhouses that do use electric boilers. So this you might consider to be maybe a less common choice. But just like a fossil fuel-based boiler, they can be connected to hydronic heating systems, heat pipes, finned heat tubes, any sorts of electric heating systems that are going to be routing hot water can be sourced from an electric boiler just as much from a boiler that's run by propane or natural gas or steam or anything like that. Yeah, I would just mention that they're not an extremely common choice, as you probably can tell from the cost of electricity, and the fact that boilers, they can't, like a heat pump, have a efficiency that's greater than one. And so the last two slides of this presentation are about heat pumps. And while they are electric based, they do have a coefficient of performance which is greater than one. And that means that they can take an electric unit of energy input and actually multiply it by using the heat pump process, which is a thermodynamic process that takes refrigerant and essentially takes the performance of that refrigerant and amplifies that electric energy to have an output that's sometimes something like 3 or more. So on the next slide, we're talking about air source heat pumps. Air source heat pumps are taking the air outside, whether it's cold, hot, whatever temperature it is, they're taking it in and they're running it through that refrigerant cycle, and they can heat or cool depending on what your goal is. And so they can be used year round. They have a high coefficient of performance, generally greater than 2, sometimes close to 4, depending on the style of system and how high performance the refrigerant is. But a note as well, just like the electric-based systems that we mentioned before, these aren't incredibly common in the US yet. Electricity prices compared to fossil fuel prices here generally make these not as attractive of a choice as some of the others we've mentioned before. One thing I did not mention in the beginning is that unit heaters outside of boilers and other sorts of systems are generally the more common choice. Like 60% of grower dollars on heating are spent on unit heaters. So if we think about the rest of the 40% of dollars, there may be spent on boilers in some cases, but even a smaller contingent is spent on heat pumps and other sorts of systems like this. There are programs
Yeah.
that want to incentivize the use of heat pumps, though, so that can be a way to make these systems more cost effective.
And I was looking up some stats. So this photo actually comes from a research project that came from a colleague at the University of New Hampshire. And so they had two side-by-side greenhouses. One had fuel oil to heat the greenhouse, and then one had these air source heat pumps plus fuel oil as a backup. And what they found in that particular study, I'll forget the dimensions of the greenhouse, but they heated the greenhouse from February to April, kind of like a spring bedding plant grower would do. The greenhouse that only had the oil furnace burned 700 gallons of oil versus the heat pump system. The heat pump operated, plus they burned 450 gallons of oil to make up for heat on like cold days, for example, when these systems aren't very efficient at extracting. So they used $145 of electricity. So essentially, in that project, they saved 250 gallons of oil for $145 electrical cost. So there were real savings for them. But in general, as Gretchen was kind of getting into, these aren't so common yet in greenhouses. They're more common in residential houses where we have more insulation and don't need systems with as high of a capacity as a greenhouse.
Or in lots of commercial buildings. You'll see them all over in
Good point. Yeah,
buildings with
yeah.
humans have
Hmm.
these. Not as many buildings with plants do yet, but we do see this as something that might start to be demonstrated more, especially as fossil fuel costs continue to increase and potentially electricity costs continue to be more like a cost parity for heating as electrification programs offer more incentives for these equipment, as well as potentially there's also things like electric rates for heat pumps in some places. So you
Hmm.
might find that you
Hmm.
have a cost-effective rate to choose from your utility if you operate systems like these. Um, so we mentioned on the slide that these often require a backup heating system, but they don't always. In a greenhouse, though, I would recommend generally having a backup heating system for those other reasons I mentioned. But in greenhouses, because they have a less insulated thermal envelope, it can often be good to have a backup, especially for those extremely cold days.
That's
Um,
right. And the cooling component we should not forget as well, which can be quite interesting. So we're talking about these for like heating in the wintertime, but they are dual purpose in many cases where they can extract cooler temperatures from outside and give you cool air in the greenhouse. And increasingly, we are seeing greenhouse operations that instead of being open air ventilation to cool, they do calculations and figure out what times it economically makes sense, where instead of venting that greenhouse and then losing a lot of waste heat and kind of reheating the greenhouse after venting, they could just operate these to cool it down if they just need a moderate amount of cooling.
Yes, so sealed greenhouses, ones that are not going to be doing a lot of ventilation through the roof, fence, or sides. If they're going to be more sealed, heat pumps are often a better solution because they are going to be more like performing inside a commercial building. They're not dealing with all the openings of a greenhouse. And we see these sometimes in cannabis greenhouses where they aren't interested in having the air get exchanged with the outside due to odor laws or other sorts of reasons. And so I've seen some air source heat pumps in those sorts of crop applications, as well as, like Neil mentioned, in crops that might need more cooling. And so with sealed greenhouses, on the next slide, we find that ground source heat pumps or geothermal heating and cooling can be a viable solution, especially when they're going to be highly insulated or in a climate that needs a good amount of heating and cooling. And so when you have kind of a good demand both sides of the seasons, geothermal is a really
Mm.
good choice. It is the more expensive heat pump choice, but it generally doesn't require a backup. It might be something that you still have some N+1 to protect from if there's emergencies or equipment failures, but there isn't generally a requirement that there be a backup because the system can handle extremely cold temperatures and extremely hot temperatures because it's getting its input air from piping buried in the earth. So that's generally always around 55 degrees Fahrenheit.
And I know household residences are also adopting more geothermal heating. We don't see a ton of it yet in commercial greenhouses. I visited one commercial greenhouse that installed it, and I think the main barrier for them was the really high installation cost. So it's not like a 2 or 3 year return on investment. It's like a several year return on investment, at least before incentives, and then maybe you can get energy
Yeah.
incentives to help.
Thanks for mentioning incentives. I'm working with a greenhouse I would say it's like a multinational company with many research greenhouses. This would be the sort of entity that can kind of handle the long payback periods of geothermal. And they are working to get rebates from their local utility company, which will help offset the first cost of the higher performance envelope, the higher performance heat pump systems, as well as the controls and the lights. So when a greenhouse is considering maybe the higher end of all like the works and all the different systems, geo can be a good one to consider in that kind of library of things to add to a really efficient greenhouse. And that will be our next topic for our final video in the series. So thanks for watching so far, and we hope that you join us for the last one.